Okay, College Algebra Trig. Now we're going to do trigonometric functions involving angles or rotations. This is section 5.4 in your textbook, and this will be the last installment of our online series while I'm in Guatemala. And when I get back, we will answer all questions from these sections. So hold all your homework and hold all your questions. I'll answer them when I get back, and then you can turn in all of the homework that was assigned over this time that I've been gone. Okay, take a look. I'm going to draw a little picture here. Take a look at the picture. Now, we talked about trig functions in 5.2. and we considered a point on the unit circle. So now we're going to talk about points on circles other than a unit circle with radius r. So basically it's going to extend the discussion we had before, but we'll extend it to a circle of radius r units, not necessarily equal to 1. So let's say this inner circle is the unit circle. Let me draw a line through the origin. And what we have is an angle theta that's formed by that line. And let me draw a point here. The radius on the inner circle is 1. That's your unit circle. And the radius on the outer circle is r. Alright, so this r doesn't mean just this short distance between the 2 points, but this r means this radius for the bigger circle. Let me drop some perpendiculars here. And here's origin. I'm going to call that point M. Call this point N. Alright, and let's say this is Y1 and this is Y. These vertical distances from M to the point there. This point is going to be T. And this point here is P. So T has coordinates x1, y1. P has coordinates xy. This is a little bit messy. There's a nice picture on page 397 in your book. So notice that we form similar triangles here. We've got basically a triangle, basically two similar triangles like this, and that's T, that's P, M, N, and O. Alright. So since we have similar, these are actually similar triangles from, that's an idea from geometry, and since they are similar triangles, certain sides of these have the same ratios. For example, we have MT divided by OT would equal NP divided by OP, right? MT divided by OT would equal NP divided by OP. MT over OT would equal NP over OP. Now, what is MT? MT, that's your Y1 there. And what is OT? That's OT, so that's the radius of the unit circle 1. And what's NP? NP is Y here. and OP is the radius of the big circle R. Alright, so Y1 is equal to Y over R. Now, what is Y1? Y1 was on point T here, which is on the unit circle. It's the y coordinate of point T on the unit circle, and remember that was sine theta. Y1 is sine theta, X1 was cosine theta on a unit circle, right? So that means sine theta is Y1, and that equals Y over R. Y over R. Here's your Y, here's theta, and this distance was R. So sine of theta is Y over the hypotenuse R of that big triangle there. Now, does that look familiar? Sounds like right triangle trigonometry. Similarly, we have OM over OT equals ON over OP by similar triangles. OM over OT equals ON over OP. And what is OM? OM is, OM is this distance right here, and that's actually where X1 is located on point T. So OM is X1, and as you can see, OM is the distance between here and here, and that's actually X1 on that point T there. Alright, so OM is X1. OT, what's OT? That would be this distance, or the radius of the unit circle, which is 1, equals ON. ON would be here to here. That's this distance, which is actually Y, or rather not Y, but X, on point P. So that's X over OP. OP is this distance, which is the radius of the big circle R. So X1 is equal to X over R. Now X1 again is the point on the unit circle for the X coordinate of the point T on the unit circle, and that's actually cosine theta, which we've seen before. So that's cosine theta is equal to X over R. Cosine of theta, this is X, this distance, ON, over the hypotenuse, R. Side adjacent over hypotenuse. Alright? Alright, now tangent theta is sine theta divided by cosine theta, and sine theta is Y over R divided by cosine theta, which is X over R. So here we have sine theta, Y over R, and cosine theta is X over R. So that's Y over R times R over X. Cancel the R's, you get Y over X. So tan theta is Y over X. Alright? And if you look at the triangle, Y, this distance here, is X. Side opposite over side adjacent. Right? Preview of right triangle trigonometry. Or maybe it's a review for some of you if you've studied right triangles before. Alright. So, the point P, right here, which is a point other than the vertex on the terminal side of the angle, can be anywhere on a circle of radius R, and its coordinates may be positive negative, or 0, depending on the quadrant in which the terminal side lies. And in other words, if this is way over here, the x-coordinate would be negative. The length of the radius, which is the hypotenuse of what we call the reference triangle, is always considered positive, and the angle is always measured from the positive half on the x-axis. So what we have then is sine theta is y over r, cosine theta is x over r, and tan theta is y over x. So this large triangle here is called the reference triangle. All right. And the length of the hypotenuse, or the radius, is always considered positive. So that gives you a table on page 399 in your book, which you would want to look at. We've got sine, cosine theta, sine theta, cosine theta, tangent theta, and also we have cosecant theta, secant theta, and cotangent theta there. Well, let's actually do some examples.